Hi guys. Today we want to talk about non-compatible thermostats and also some home damage related stuff on this training. So there are quite a few systems out there that we're starting to find out that aren't compatible. There's some that we've known about from the start, but it seems like every year new stuff keeps popping up. So we just want to talk about a few of the more common ones, and we'll move on from there. So first off, some of the requirements to our CT100 thermostats. First, the voltage range is 12 to 24 volts. So basically, if the wires are small enough to fit into the terminals on our terminal strip right here on the CT100, usually your voltage is going to be okay. If you do want to check it, you can always pull out your multimeter and also check the voltage. Another requirement for this thermostat is you need to make sure the customer's original thermostat, their terminals, are matching the terminals on the CT100. So if you look here, we have our CT100 terminal strip. We want to make sure that the customer's terminals are matching those. If we start to see terminals that don't match or terminals we've never seen before, it's always a good idea to either call your head tech or call myself, and we can confirm if this is going to be a system we can take over or not. But also make sure you use your tech binders, and experienced technicians also have a lot of knowledge on this. So try to utilize all the tools that we have out there. So voltage and the terminals need to match. Those are the requirements for our thermostat to be taken over. Now, starting out with some of the non-compatible thermostats, these two right here, we have the PID thermostat and the Honeywell IAQ thermostat. These two thermostats, the reason we have them both on this slide is they use really similar terminals. You can see that they use terminals that are labeled ABCD 1, 2, 3, 4, or ABC 1, 2, 3. Now, these thermostats on the PID side, these can use power and data, and these can cause really expensive home damages if we try to hook up to the CT100 to one of these systems. So we want to make sure that we don't try to hook up to these, and the reason some technicians do it is instead of going off of the terminals like A, B, C, D, they look at the color of the wire, and if they think that the color of the wire actually matters, they would try to match up, the green to G or the red to R. And in the HVAC industry, on the thermostat side of things, the color of the matter doesn't, or the color of the wire doesn't matter. So we want to make sure that we're going off of the terminals and not the wire color. On the Honeywell IAQ side of things, these thermostats have a control module that sits in between the furnace and the thermostat, and these actually communicate back and forth. And if we connect our thermostat to one of these systems, we can damage that control module, and those can end up being pretty expensive home damages as well. So just remember, on these, it's all about the terminals. You pull the thermostat off the wall and you see terminals that are labeled ABCD or ABC or 1, 2, 3, 4 or 1, 2, 3. Make sure we don't connect these. We just can't take these over. All right, some more non-compatible thermostats. These two are made by Carrier and Bryant. Now, there's the Carrier Infinity system and the Bryant Evolution system. Now, these are proprietary thermostats that only work with certain equipment manufactured by these two brands. So basically, if we try to take over one of these thermostats, we can damage control modules in the furnace. We can damage control modules that sit outside the furnace. However, these are communicating to the equipment. These can actually be really expensive home damages. So again, identifying these types of thermostats, it's going to come down to the terminals. So on these, they like to use terminals that are labeled VG, V+, R, RS. Now, it can be all sorts of different combinations of these two. Sometimes I've seen these where there's just 2 wires. Sometimes I've seen all 4. So keep that in mind, that these terminals, again, make it so it's not compatible. We can't take it over. All right, I've been getting calls every year on this type of thermostat. This is a Honeywell wire saver thermostat. Sometimes you'll see these are actually installed by power companies in certain states. Now, the identifying factor on these thermostats is these will have a K wire. Now, in a lot of cases, they'll have an R wire, a C wire, maybe a W or a Y, and then they'll have the K. Now, what happens with these thermostats is these thermostats can actually make a 4-wire system work as a 5-wire or a 6-wire. However many wires you need, it can actually convert a 4-wire into one of those types of systems. So the K wire actually takes care of a lot of different modes. Now, if we try to connect to one of these, you can see this little control module we have on the left-hand side. This is what does the communicating between the equipment and the thermostat, this little module can actually get damaged. And so we want to make sure if you run into a Honeywell thermostat that has a K-wire, like you can see on this picture right here, a K-wire connected, we can't hook up to these. These are considered non-compatible. All right, this one, hopefully everyone knows about this, but high voltage. We can't take high voltage thermostats over. So, like I said earlier, our thermostat range, or voltage range on our thermostat's 12 to 24 volts. Anything above that, we can't do it. So, first off, the way to identify these is the wires, the thickness of the wire. You can see in these pictures, we have this thermostat on the right where the wire is very thick. We're looking at either 6 or 8 gauge wire. Same here on the left-hand side. So if you see thick wire, just don't even mess with it. We're dealing at that point with either something in the 110 to 240 range, and that's voltage we just don't want to mess with. It's the same reason why we don't take over Z-Wave, or we don't install Z-Wave light switches and things like that. So anything high voltage, we don't mess with. All right, so we want to transition over to Trane American Standard systems. So we've talked about this in some other trainings, but just want to review it because Trane American Standard can actually cause a lot of home damages when it comes to blown fuses and blown transformers. So a few things to remember about this is when it comes time to identifying Trane American Standard systems, look for the brand name. They like to put their brand name on everything. So you can see, for example, on these thermostats down here, you see Trane American Standard. Now, the reason we want to be able to identify these is Trane American Standard do things a little bit differently. They don't have C wires on their thermostats. They don't use C for the 24-volt common like we do. They use the B terminal. So the main rule to remember about Trane American Standard is B goes to C. If you can remember that, that will save yourself a lot of headaches. But a few things that will help you identify these is, first off, look for the brand name like I said. You see Trane American Standard, just remember there's something up with this. If that is all you can remember, that's good enough, because at least you can remember, hey, I need to ask somebody about this, or I need to look at my tech binder and confirm that, hey, I remember something about Trane American Standard, I just can't remember what it was. That's enough. So if you see those brands, hopefully that triggers something and you can remember to at least ask or start looking in your tech binder. Another thing to look for is if you see a thermostat that has a B and an O wire wired up at the same time. So the rule with our thermostat with the CT100 is you'll never wire up a B and an O together. So if you see a thermostat that does have a B and O wired up at the same time, that should also send up a red flag. And hopefully you can remember, all right, B and O wired up at the same time, I'm never going to do both of those. Then you have to just figure out where the two terminals are going to go. The way I do it is O doesn't have any other uses. O is always going to be a reversing valve, especially for our thermostat. So if I see an O, I'm automatically going to put the O into the O terminal on our thermostat. At that point, I have to figure out what the B is doing. So again, the rule is you can't have a B and O wired up at the same time, but there is some other exceptions to that rule as far as Trane goes. So I'm going to say, okay, I have a O already wired up, and there is still a B left over. B goes to C because sometimes Trane American Standard has the B is the 24-volt common wire. So hopefully that will help you remember. Another thing you can do is if you get to the customer's thermostat and they have a B wire connected, what you can do is you can pull the batteries out of the customer's thermostat. If you pull the batteries out of the thermostat and the thermostat stays lit up and there's no C wire connected, there's something giving it power. And if the batteries aren't giving it power and the C wire isn't giving it power, my next option is I'm looking to see if there's a B wire connected, because that's another option for a power wire with thermostats. So I know a lot of these aren't perfect ways to figure it out, but hopefully these are ways that at least get you to the point where you start asking questions or you start looking things up. It's a lot easier for you to make a phone call to myself or to your head tech and ask what's different about Trane or American Standard, or what do I need to do with those systems, than it is to make the phone call after you've tried to hook this up incorrectly and you've blown a fuse or a transformer. Because what happens is if you wired this up wrong and you put this B wire into the B terminal on our thermostat, what will happen is the second you turn power back on, the fuse will blow, because the R terminal, or the R wire on our thermostat, will eventually energize the B terminal on our thermostat. And if you ever have a R and a C wire touch, that's a direct short on the transformer, and that's going to be a blown fuse or a transformer every time that happens. So keep that in mind. You always want to make sure that on Train American Standard, the B goes to C. And again, just always ask questions, make phone calls, look at your tech binder, and that will save you a lot of headaches. All right, so now we're going to talk about preventing home damages. So the first step when it comes to preventing home damages is testing the customer's equipment. So you can see in this picture that we have one of these infrared thermometers. It sends off a little laser, and you can actually read surface temperature on certain things. In this case, they're reading a temperature off of a heating and air conditioning vent. Now, in all of your toolkits, you're going to be receiving one of these thermometers. And we want you to be able to use these because in some cases when you go into a customer's home, and I've heard of a lot of technicians doing this, they walk in, they put their hand by a vent, they feel air, and they automatically just assume that since they feel air, it's working. But they haven't confirmed if that air is warm or if it's cold. It's just air. And so in that case, maybe the fan's working, but maybe something's wrong with their system and the system's not working correctly. So when it comes to testing the customer's equipment, what you're trying to prevent is getting stuck with a home damage that you didn't cause. There are going to be systems out there that have issues going on before you even walk into the house. And if you don't test the equipment, you don't catch that problem before you install our thermostat, a lot of times the customer will call in and they will get that replaced, and Vivint will pay for it because home damage or whatever department's dealing with that automatically assumes that we caused it since we were the last ones to touch the system. So we want to make sure you test it. You're taking temperature readings with your thermometer to make sure everything's working on the heat and the cooling side before you ever do the install. If it's not working, we want to make sure that we just talk to the customer, let them know that the system isn't working, and we're more than happy to come back out and do the install when the system is working. You can still finish everything else on the install, but when it comes to the thermostat, we don't want to install the thermostat until everything's working 100%. So definitely use those infrared thermometers that you're going to receive in your toolkits. Make sure you're confirming that it is warm air blowing through the vents in heat mode, and it is cool air blowing in the vents for cool mode, and just save yourself a lot of headaches on that. So testing is very important. All right, so the next step to preventing a home damage is turning off power. Now, this is one of the most obvious steps to an install, but it's one that gets forgotten, or it's done incorrectly a lot of the times, and we get a lot of home damages from that. And the most common home damages that come from this are blown fuses and blown transformers. Now, if we turn the correct power off to a system, your chances of blowing a fuse or a transformer drop dramatically, because once you turn power off, you've killed power to the wires, and now it doesn't matter if wires are touching, you're not going to short anything out. But if you turn the wrong power off, or you don't turn power off at all it takes is for the R and the C wire to even get just close to each other, and that can cause a direct short on the transformer, and that's where we see fuses and transformers getting damaged. So make sure we're turning off the power. Now, the power that I recommend that you turn off is the power located directly at the furnace or the air handler inside the home. The reason we want to turn the power off to the inside unit inside the home is that's where the transformer is located. And the transformer is what's sending power up to the thermostat, to the R and the C wires. So if we turn power off to that system, we're going to kill power to the transformer, which then kills power to your R and C wires. And at that point, you can safely install the thermostat with it without any problems. So the inside unit's what we'd want to turn off. So in some areas where furnaces are in garages, or sometimes they're just in closets somewhere, those are easy to access, and we can turn power off right there. But I know in a lot of areas, these systems are up in attics or in crawl spaces, and they're not very easy to get to. In that case, the breaker box will work just fine. But we want to make sure that you're turning off the correct breaker. A lot of times when you start working on these breakers, you'll notice that some aren't labeled at all, or some are labeled incorrectly, and technicians go and they turn the breaker they think is the right one off, but it wasn't even powering up the inside unit, and they still end up blowing a fuse because they turned the wrong power off. So Make sure if you're going to turn off the breaker, I like to let the system run so the fan is still running and you can hear the fan. And when you get the correct breaker turned off, that fan will stop running inside the home, and that confirms that you have the inside unit power turned off. So if it's the switch or if it's the breaker, I don't care, as long as you just get the correct power turned off, and that can save you a lot of headaches when it comes to fuses and transformers. All right, the last way to kind of prevent home damages is it's always a good idea to take a picture of the customer's existing wire before you unhook it from their thermostat. The reason this can prevent home damages is this gives you something that you can refer back to make sure that you get the correct wires in the correct terminals. Because all it takes is just putting the wrong wire into the wrong terminal, and that can either blow fuses and transformers, or that can cause the wrong system to turn on in the wrong mode. And if it doesn't get caught, if that runs for a long period of time, that's never a good thing for the customer system, and it doesn't help when it's the summertime and maybe their heat's working instead of their cooling. So customers don't like that. It can cause problems, and it can also blow fuses and transformers. So if you take a picture of the customer's wires, it takes all the doubt out of play, and you can just refer to your picture and make sure that you're getting the correct wire in the correct terminal. And this year, with technicians receiving iPads to do their electronic tickets, it should make it even easier to do this, since all your iPads will have cameras and you can just take pictures. So make that a habit that you get into. That's definitely a good habit, especially when it comes to thermostats, just taking pictures of the wires before you unhook the wires. All right, so home damages. It seems to happen to everybody that you'll end up causing home damage. And this goes for thermostats, this goes for any other home damage related to any part of the install. But something you need to do before you ever submit a home damage claim is to call your head tech. You always want to call your head tech before you submit a claim, because there's always a chance that your head tech can actually come and fix the system or fix the problem, and this could end up saving the company a lot of money. So if you ever have problems or you ever think you've caused a home damage, always get into the habit of call your head tech. Now, when it comes to HVAC problems, you can call me as well over the phone, and sometimes I can help walk you through some troubleshooting, and there's even a chance that I might be able to help you fix the system over the phone. So always try to call me or call your head tech when it comes to these things, because if we can save a home damage, that saves you headaches. It can also save you some money when it comes down to things. So always get into that habit. Call your head tech before submitting a home damage claim. So that's our training. This is my information. If you have any questions, give me a call, send me an email, and thanks for listening.